Have you ever stopped to think about what actually happened to make our phone's internet so ridiculously fast? We went from painfully slow to basically instant. Today, we're going to pull back the curtain on the technology that made it all possible, LTE.
Oh man, I think we all remember the 3G days, right? You'd tap on a link, and then you'd just stare at that little spinning wheel of doom. It felt like forever. And then, boom, LTE shows up. Suddenly, videos just load. Web pages just appear. The mobile internet finally became what we always wanted it to be. Fast, seamless, instant.
So, what was the secret sauce? What was the fundamental change under the hood that allowed for this huge leap in speed and responsiveness? Okay, let's dive in and really map out the brilliant design behind LTE.
We're going to break this down into 5 parts, nice and simple. First, how the network is split in 2. Then, we'll get to know the super intelligent cell tower. After that, we'll explore the network's core, see how all the pieces get wired together. And finally, we'll understand why this design was such a total game changer.
You see, the whole revolution started with a really radical idea. Just make it simpler. The engineers behind LTE decided to create what they call a flat, all-IP architecture, which, is just a fancy way of saying they got rid of a ton of unnecessary parts and streamlined the whole thing. So they split the entire system into just 2 main parts. That's it. On one side, you've got the EUTRAN, what a mouthful, right? It just means everything to do with the radio waves connecting your phone to the cell tower. And on the other side, you have the EPC, the Evolved Packet Core. Now this is the brains of the operation, managing who you are and how your data actually gets out to the internet.
Okay, so let's start with that first half, the radio side. Unlike the old networks that had all these different boxes doing different jobs, the LTE radio network is built around one single, incredibly smart component.
And here it is, the E node B. The E stands for evolved, and trust me, it really was an evolution. See, back in the 3G days, you had a basic radio tower, and then a separate controller, often in a different building, telling it what to do. The absolute genius of LTE was to take all that intelligence from the controller and build it directly into the tower itself. That one move cut down the travel time for signals like crazy, which is the key to getting that low latency, that snappy feeling.
So this smart tower is a serious multitasker. It's like an air traffic controller for radio waves, deciding which phones get to talk and when. It also encrypts all your data to keep it secure, and it cleverly routes your traffic. It sends the management messages one way and your actual data, your videos, your web pages, a totally different way.
All right, so let's leave the tower and head deeper into the core of the network, the EPC. And this is where we find another brilliant idea, a separation of duties that makes LTE so incredibly efficient.
The EPC is split into 2 planes. Just think of the control plane as the brains. It handles all the thinking and the logic, figuring out who you are, checking if you've paid your bill, and setting up your connection. Then you have the user plane. That's the muscle. Its only job is to move your actual data as fast as humanly possible. No thinking, just pure heavy lifting.
And the king of the control plane, the head of the brains, is the MME, the Mobility Management Entity. This thing is pretty much the command and control center for the entire network.
Yeah, a great way to think of the MME is as the network's traffic cop. So when you turn on your phone, the MME is the first thing to greet you. It checks your ID, tells the network to build a data-gated data pipe just for you, and it keeps tabs on where you are so it can route calls and data to you.
But wait, how does the MME even know who you are? Well, it has to ask the HSS, or the Home Subscriber Server. This is the network's super secure central database that holds information on every single customer.
The HSS is basically the master database. It's got the whole file on you, what data plan you have, the secret security keys that verify your SIM card is legit, and it even keeps track of which MME is currently handling your session. It's the ultimate source of truth for your account.
Okay, so that's the brains. Now let's switch over to the muscle, the user plane. The very first stop for your data after it leaves that smart cell tower is the SGW, or Serving Gateway.
The best way to think of the SGW is as an anchor for your data session. Imagine you're driving down the highway, right? Your phone is constantly hopping from one cell tower to the next. The SGW provides one stable, single point for all that data to flow through, making sure your Spotify stream or your phone call doesn't drop. It is the rock-solid connection point in a world where you're always on the move.
And finally, your data has to actually get out to the big, wide world of the internet. And that's the job of the PGW, the Packet Data Network Gateway.
The PGW is the ultimate doorway to the internet. It's the bouncer at the club door. It gives your phone its unique IP address, it connects you to the public internet, and it enforces the rules, like making sure your voice call gets priority over some background app update. Every single bit of your data has to go through this gateway to get in or out.
So we've got all these specialized pieces, right? We have the smart tower, the traffic cop, the database, the anchor, and the doorway. But how do they all work together so perfectly? Well, they communicate over these very specific, standardized pathways called interfaces.
Now, I know this table looks kind of complex, like alphabet soup, but it perfectly shows that separation of powers we've been talking about. Just focus on the first two. The S1 MME interface is a dedicated line for brain traffic, the signaling between the tower and the MME. And at the same time, the S1U is the superhighway for the muscle, for your actual data, running between the tower and the SGW. This core split between signaling and data is what keeps everything so organized and unbelievably fast.
So now that we've seen all the parts, let's bring it all home. Why was this new architecture so much better? Well, the crucial point is that this super elegant design gave us three massive advantages.
First, by getting rid of that middleman controller and putting the smarts right in the tower, latency just dropped through the floor. Second, letting towers talk directly to each other made jumping between them, the handover, smoother than ever before. No more dropped calls. And finally, by separating all these jobs, MME for brains, SGW for muscle, the phone companies could upgrade and scale each part of their network on its own. It made the whole system stronger and easier to grow.
You know, when you really look at it, the story of LTE isn't about adding more complexity. It's about intelligently taking it away. This flat architecture was truly a masterclass in simplification, and it's what paved the way for the mobile internet that we pretty much take for granted today.
From that smart tower to the clean separation of brains and muscle, every single piece of the LTE puzzle was designed for one thing: speed and efficiency. It really was a revolution. Which, of course, leaves us with one last question to think about. What's the next evolution in network design going to bring? Thanks for tuning in.